This is Unit 2, Segments, Lines, and Angles, Preview Video 2.7, Part 1, Parallel Lines and Angles. Take a moment, close your eyes, and inhale through your nose. Hold your breath. Slowly exhale. Taking a look here, don't forget your date, time, location, and a parental sign-off. We're going to be looking at specifically parallel lines. Parallel lines. Key words here. The word skew, alternate interior, alternate exterior, corresponding, consecutive interior, vertical angles, a linear pair. I'm going to be making reference to a stir stick or a coffee stir stick. It's really important that you have some sort of item that's thin and long. You can use a very thin pencil. If your family has a coffee stir stick around somewhere, that might be very helpful, or a thin straw of some sort, but a physical prop, some sort of thin, long, physical prop would be very helpful. We're going to be talking about parallel lines. There are parallel lines in thousands of architectural situations. Without parallel lines, we would not have transportation, we wouldn't have buildings. Almost every single architecture, save curved domes, involve parallel lines. There's two different terms here. Two different terms. I'm going to be using blue and red to color code something here. Blue and red. Trace these lines, please. Stretch them out. Those lines are on the same plane and they go the same direction. Same plane, same direction. When we mean plane, we mean like a flat surface. So they're on the same flat surface going the same direction, but they never intersect. Those would be considered parallel lines. We use these little arrow feathers to represent parallel lines. Skew are never intersecting lines as well, but two distinct planes or two different directions. So these red lines, if you imagine this in 3D, 3 dimensions, these two lines are not on the same plane. They're on two different planes. And they go two different directions, but in 3D space, they never intersect. Those are called skew lines. We're going to be talking about a transversal. A transversal. A transversal is simply one line that cuts across two or more other lines. So a line that cuts across two or more other lines. That long physical object I asked you to have, if we were in classroom, we'd be using stir sticks, but you're going to have to provide that yourself. That is going to be a mock-up or a physical model of a transversal. So when you have a transversal cutting across two or more lines, the angles that are created have certain names. When I mean angles, I mean positionally. First off, when you have sets of angles which are on opposite sides of the stir stick or transversal, but between two lines. When I say between would be in this yellow space. That would be between the lines, but opposite sides of the transversal. Those are called alternate interior angles. An example of alternate interior angles, pairs of them, opposite sides of the stir stick but between the lines, are angles 4 and 5 would be a set, and then angles 3 and angle 6 would be a set of alternate interior angles. Alternate opposite sides of the stir stick, interior between the lines. Now we're going to trace a set of angles which are on opposite sides of the stir stick, also known as the transversal, but outside the lines. These are called alternate exterior angles. An example of alternate exterior, opposite sides of the transversal, outside the lines, would be angles 2 and 7, and angles 1 and 8. Angles 2 and 7, 1 and 8. Those would be considered alternate exterior. Then you have what's called corresponding angles. One set of angles which are on the same side of the stir stick, same side, but with one in and one out. These are called corresponding. They're in corresponding positions. So an example of corresponding angles would be angle 3 and angle 7. One is in the line, in meaning between the lines, one is out. But they're on the same side of the stir stick. There's actually 4 sets here. Angle 3 and angle 7 would be one set. Angle 4 and 8 would be another set. Angle 6 and angle 2 would be another set. And angle 1 and angle 5 would all be corresponding sets of angles. One in, one out, same side. The last would be these angles. One set of angles on the same side of the stir stick, but between the lines. Same side of the stir stick, but between the lines. These would be, for example, set 4 and 6. And that is called consecutive interior angles. Consecutive interior angles, also known as same side interior angles. They have 2 names, consecutive interior, same side interior. So you need to know these 4 relational terms of angles. I'm doing this page with you. You're going to lay your stir stick or whatever object, thin object you have on the red dotted line. And you're going to identify them, the angles that are given, either as alternate interior, alternate exterior, corresponding angles, or consecutive interior angles, or you also need to watch out for angles you've already seen before, such as linear pairs, share a spine, make a line, or vertical angles, also known as bow tie angles. So in this diagram, your transversal or your stir stick, darken it. If you have a physical stir stick, lay it down, is right here. Now, if that's your stir stick, lightly shade here, lightly shade. That means we are cutting across these two lines. So that lightly shaded region is considered the interior region. And then to the left or right would be considered exterior or out. So ready? 12 and 13. 12 and 13 are on the same side of the stir stick, but between the lines. 12 and 13 would be considered consecutive interior angles. Consecutive interior angles. 10 and 15. 15 is in, 10 is out. We're on the same side of the stir stick. That would be considered corresponding angles. 12 and 10. 12 and 10 consist of two straight lines creating a bow tie. So 12 and 10 would be considered vertical angles. Nine and 16. 9 and 16. 9 and 16 are on opposite sides of the stir stick. So we know it's alternate. Alternate means opposite sides. And exterior, because they're not between the lines, they're outside, so we'd call that alternate exterior angles. This page you're going to do on your own. Notice your stir stick or your transversal is changing. So now you're working with this as your stir stick, which means the lines you are cutting across are these lines right here. And what constitutes interior would be going this way. Sweep the various angles and identify. When I mean identify, I mean one of these potential 6 possibilities. 1, 2, 3, 4, 5, 6. It's going to be one of those 6. Pause the video. Restart when you're finished. So 12 and 3, 12 and 3 are alternate interior, opposite sides of the stir stick between the line. 1 and 11 are alternate exterior, opposite sides of the stir stick outside the lines. 9 and 3 are inside between the lines. That's consecutive interior, also known as same side interior. And 3 and 10, one's in, one's out, same side, that's corresponding. Now you need to know these names apply even if the lines are not parallel. But special things happen when lines become parallel. So I'd like you to trace this line. And I'd like you to trace this line. I'd like you to add these little arrow feathers. You can put them either going the same direction or you can make them go opposite directions. Both mean the same thing. Depends on the textbook. But these little arrow feathers imply that the lines are parallel to each other. So let's name these lines. We're going to name them line P and line Q. And in this diagram, line P and line Q are parallel to each other. The symbol for parallel is a double backslash. Now, when lines become parallel, these 4 different angles have certain qualities. Let me explain. When lines become parallel, alternate interior angles become congruent. So one example would be angles 4 and 5 are alternate interior angles. And when lines are parallel, those are of congruent. I'm just giving you one sample. Angle 4 is congruent to angle 5. When lines become parallel, alternate exterior angles are congruent. Alternate exterior would be, for example, like angles 2 and 7, opposite sides of the stir stick outside the lines. When lines are parallel, or if lines are parallel, corresponding angles become congruent. Corresponding angles would be one in, one out, same side. An example of that would be angle 4 and angle 8 are congruent. One's in, one's out, same side. Now, what kind of angles are also always congruent? Notice this list is all kinds of angles that are congruent or equal to each other. Vertical angles are always congruent, even when lines aren't parallel. So an example of vertical angles, again, vertical angles are what are called bow tie angles. So an example of vertical angles would be angle 2 and 3. Vertical angles directly across from each other. Those are always congruent. Now, when lines are parallel, consecutive interior angles are supplementary, which means they add up to 180. An example of consecutive interior angles would be 3 and 5. Angles 3 and 5 would be considered consecutive interior. They are not equal, but they do add up to 180. What is always adding up also to 180 would be a linear pair. Share spine, make a line. A linear pair example would be angle 7 and angle 8 would be considered a linear pair. And they are always supplementary. Now, out of all of these angles, the ones that are most critical are the alternate interior angles. Alternate interior angles. In fact, they are so critical that I have a special name for them. So when lines are parallel, and you have a transversal, you want to look for what I call armpits of the Z. The armpits of the Z. So you have like a Z formation. It can be several ways. And then if you would consider the armpits, if you will, of that Z, and I'm going to gross you out, but you won't forget, think of the hairy armpits. That's what the hatch marks are for. So the armpits of the Z, when lines are parallel, are congruent. So for example, here's your traditional Z. They are parallel. The armpits of the Z that would be congruent would be like this. Armpits of the Z are congruent, those hairy armpits. But the parallel lines could also go vertically, which is perfectly fine. So your armpits of the Z would be like this, that are congruent, hairy armpits. You have to be able to spot these. These are by far the most common, the most important. You'll see them again in physics class, aviation, navigation, many different scenarios. So in this diagram here, in this picture, if you will, some example of armpits of the Z. Assuming these lines are parallel going this way, a pair of armpits of the Z doesn't always have to face properly, would be like this. These angles right here and here would be congruent. Let's look here vertically. I'd like you to trace them. See, well, that's not straight. Let's make it straight, going like this. Therefore, armpit of the Z would look something like this. Armpits of the Z are congruent when lines are parallel. They're between the lines, between two lines, but on opposite sides. Between two lines, but on opposite sides. Armpit of the Z, and they are congruent. This is only true when lines are parallel. Watch out for those. All right, this is your last page. Let me show you what we want here. I'll give you an example. You're going to sweep angles A and B. You're going to determine both their position and their relationship when you have parallel lines. Let me give you an example. Sweep A and B. Now, A and B are on opposite sides of the stir stick outside of the lines. So, positionally, they are alternate exterior angles. What is their relationship when lines are parallel, which these little arrow feathers mean that they are? These angles are congruent to each other. So, we just write angle equals angle. Ready? Let's try another one. There's your transversal, your stir stick. And they are parallel. Look at the arrow feathers. And we have an angle, one's in, one's out. That would be corresponding angles. And what is their relationship when lines are parallel? They are of equal measure. Angle equals angle. Ready? These two angles, I'd like you to sweep them. And we are dealing with parallel lines. These angles are consecutive interior. They're between the lines, but on the same side. So that would be considered consecutive interior angles, also known as same side interior. And what is their relationship when lines are parallel? This is angle plus angle equals 180. They are supplementary. You are going to pause and you're going to do these 6 on your own and then restart the video. Pause. All right, let's see how you did. The first one, these are alternate interior and they are congruent. These guys are a linear pair, share a spine, make a line. They add up to 180. These are armpits of the Z, also known as alternate interior angles, and they are congruent. These are alternate exterior, and when lines are parallel, they are of equal measure. These are corresponding. One's in, one's out, same side, and when lines are parallel, they are of equal measure. These are vertical angles, also known as cat whisker, bow tie angles. They are always of equal measure. Very important that you actually take the time to review. There's a lot of vocabulary here. So why don't you take a moment, find yourself an audience, and explain the vocabulary to them.